So now let's look into IaC best practices. So let's wrap up this part 1 of module 4 with this section, that the best practices of infra infrastructure as code. So infrastructure as code, like software development, requires the implementation of practices and processes that allow the evolution and maintenance of the infrastructure code. So among these practices are those of software development, as in these examples, have good principles of nomenclature, do not overload the code with unnecessary comments, use small functions, implement error handling. So, but there are more specific practices that I think deserve more attention. One of them is everything must be automated in the code. When doing IaC, it is indeed necessary to code and automate all of the provisioning steps and not to leave manual steps out of code that distort the automation of the infrastructure and that can generate errors. And if necessary, do not hesitate to use several tools such as Terraform and Bash with the Azure CLI scripts. And the second best practice of IaC is the code must be in a source code manager. So the infrastructure code must also be in SCM to be versioned, tracked, merged, and restored, and hence have better visibility of the code between dev and ops. And the third one that we have in our pipeline of best practices is the infrastructure code must be with the application code. So in some cases this may be difficult, but if possible, it's much better to place the infrastructure code in the same repository as the application code. So this is to have better organization between developers and operations who will share the same workspace. And the fourth one is separation of roles and directories. It is good to separate the code from the infrastructure according to the role of the code. So you can create one directory for provisioning and one for configuring VMs, and another directory, one directory for provisioning and for configuring VMs, and another directory that will contain the code for testing the integration of the complete infrastructure. So the fifth best practice that we have is integration into a CI/CD process. So one of the goals of IaC is to be able to automate the deployment of the infrastructure. So from the beginning of its implementation, it is necessary to set up a CI/CD process that will integrate the code. So test it and deploy it in different environments. So some tools such as TerraTest allow you to write tests on the infrastructure, and one of the best practices is to integrate CI/CD process of the infrastructure into the same pipeline as in the as in the application. So next that we have is the code must be idempotent. The execution of the infrastructure development code must be idempotent. That is automatically executable at will. So this means that scripts must take into account the state of the infrastructure when running it and not generate an error if the resource to be created already exists, or if a resource to be deleted has already been deleted. So we will see that the declarative languages such as Terraform take on the aspect of idempotence natively. So the code of the infrastructure, once fully automated, must allow the construction and complete destruction of the application infrastructure. So the seventh best practice that to be followed is to be used as documentation. The code of the infrastructure must be clear and must be able to serve as documentation. Indeed, infrastructure documentation takes a long time to be written, and in many cases, it is not updated as infrastructure evolves. And the eighth one is the code must be modular. In an infrastructure, the components very often have the same code. The only difference is the value of their properties. Also, these components are used several times in the company applications. So, companies applications, it's therefore important to optimize the writing times of code by factoring it with modules for roles and for Ansible, that will be called as functions. Another advantage of using modules is the ability to standardize resource nomenclature, resource nomenclature and compliance on the some properties. And the last but not the least best practice to be religiously followed is having a development environment. A development environment. The problem with IaC is that it is difficult to test its infrastructure code under development in environments used for the integration and to test the application, because changing the infrastructure can have an impact. It's therefore important to have a development environments even for IaC that can be impacted or even destroyed by any time. So for local infrastructure tests, some tools simulate a local environment such as a Vagrant, basically Vagrant from IaC Corp. So if it is in your local machine, if you want to create a virtual machine, so Vagrant is more than enough. So you should use them to test the code script as much as possible. Of course, the full list of good practices is longer than the list that I have just shown you. So all methods and processes of software engineering practices are also applicable. So IaC is therefore like CI/CD processes, a key practice of DevOps culture that allows by writing code the deployment and configuration of an infrastructure. However, IaC can only be effective with the use of appropriate tools and the implementation of good practices. So, in this part of module 4, that DevOps and IaC, we saw that DevOps culture is a story of collaboration, processes and tools. Then we detailed the different steps of the CI/CD process and explained the difference between the continuous deployment, continuous delivery. Finally, the last part explained was how to use IaC with its best practices. So, in the next part of module 4, we will start with the implementation of IaC and how to provision an infrastructure with Terraform. Then we will go to the Ansible and we'll see how to configure the infrastructure using Ansible, and finally we use Packer to template this configuration, and how to use Packer to create numbers of huge numbers of similar kind of servers.